Hello and welcome everyone to today's cloud coaching session on extracting value and managing the lifecycle of JSON data with Oracle Cloud Infrastructure. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today, we're excited to dive into how Oracle Integration Cloud streamlines cloud application database data exchange using JSON, and to explore the advantages of leveraging Autonomous Database with its robust PL/SQL functions for efficient JSON data storage. We will also be recording the session, and you'll receive the recording via the same email that you registered with for today. If you have any questions during the webinar, please drop them in the Zoom chat and the Q&A areas, and we'll be ready to help answer them. We've also set up a channel in our developer public Slack called Cloud Coaching North America that you can access at the QR code here or at bit.ly/odevrel_Slack. We'll leave the channel open after the event to contact us directly with any questions and to share resources with you. So today's webinar will be presented by Derek Cameron, Master Principal Cloud Architect, and Wilson Randall, Cloud Solutions Engineer specialized in integration. So without further ado, I will hand it off to Wilson.
Thank you, Tara. So before we get into the actual use case demo and discussion, wanted to first introduce Oracle Integration Cloud as it fits into our situations that we've discovered and uncovered with today's webinar. So Derek and I work on what's called the Code Innovate team at Oracle, and it's a structured program, and we work with various customers on building out various use cases. And we came across some themes when we were doing some integrations with various systems that I'll show in just a minute here. But it started out with some very straightforward, some very high level, understandable requirements of, hey, we've got some customers that we're working with where they want to build out integrations, they want to pull data from various services, and they want to push that to, in our case, an autonomous data warehouse for, enterprise data storage, for analytics, for reporting, very, very high level, very straightforward kind of ask here. Hey, I want to manage my data better. I want to get some value out of it. And when this use case comes up, some various situations that we discovered were, in two use cases that we'll explore in a little detail from the integration side, is that sometimes it's a little difficult to manage that data. Sometimes, the data that's coming from Fusion or from Oracle SaaS or from, in our case, a B2B or EDI document translation use case can have all sorts of nested arrays and kind of a more sophisticated or complex data structure. Now, before we get into kind of the specifics and dig into the demo there, I wanted to first introduce Oracle Integration Cloud as kind of our source for this use case or for these particular use cases. And the reason being is when we were uncovering these use cases, a lot of our data did come from these various sources, and Oracle Integration Cloud kind of serves as this funnel to pull from these various applications and services, ultimately, giving that data to this JSON ingestion process into Autonomous Data Warehouse. So I'll be referring to Oracle Integration Cloud as OIC. That's just the abbreviation for that. So think OIC, think Oracle Integration Cloud. So at a high level, Oracle Integration Cloud is an enterprise-grade integration platform, application integration platform provided by Oracle. It's a cloud service. So it runs on OCI, on Oracle Cloud Infrastructure. And it is a very common and very recommended way from the Oracle side to integrate between applications to applications, applications to database. It is really this whole comprehensive enterprise integration platform. Now, there are some other supporting components to OIC. We won't be going too in depth into those today, but they are process automation for kind of human workflow approval type use cases, visual builder for spinning up your own custom application in a low code development environment. And then there's also integration analytics and all sorts of monitoring and tracking tools within the integration platform. Really, this core application integration platform is where is really kind of the core functionality of OIC, and that's connecting to these various applications, pulling your data, orchestrating these flows, which I'll show a little bit of in just a minute. Deployment flexibility. So OIC is a cloud-based solution, but it can also connect to on-premise applications or applications that are behind a firewall. And then there is also an API gateway that's offered from Oracle as well. So those play hand in hand with OIC, integration platform, API gateway, natural combination. So this is a list of some of the adapters that are available in OIC. This is the way that Oracle Integration Cloud actually connects to these various applications and services and actually orchestrates that data, allowing you to, touch it, translate it, move it, do whatever you need to do in connecting to these various applications. So you'll notice a lot of Oracle services, a lot of Oracle applications are provided out of the box. No surprise, Oracle connects and integrates with Oracle very well. So you've got a host of Oracle Fusion SaaS adapters, you've got NetSuite, EBS, JD Edwards. And then there's also some third-party adapters as well. So Salesforce, SQL Server adapter, Workday, and some other out-of-the-box adapters provided by Oracle. There's also technology adapters. So if you've got an API or a web service or a FTP file server that you want to connect to, you can also, pull from those data sources or push to them or interface with them however you need to if you have that interface available to you. These adapters are created and maintained by Oracle, and this list is constantly growing, especially with the new generation 3 that was just released recently and continues to be developed. So some common use cases for integration. So we frequently see a lot of integration use cases with Oracle Fusion and other larger applications. Could be cloud-based, could be on-prem, EBS, ERP, doing a whole lot of different standard orchestrations with that. Database operations, which kind of goes hand in hand with our use case. So, if you are connecting to a database and wanting to insert some data or, link up application data, safe keep it with an enterprise grade Oracle database or autonomous data warehouse, very common use case for that. There's a whole host of other common types of use case as well. So file-based import export, I'm pulling a file from an FTP server, going to hand that off to ERP Cloud, to Oracle Fusion. B2B transactions. So there's a B2B platform that's included in Oracle Integration Cloud. And we will be going into that in just a minute. And then there's also some use cases involving like application extensions. But a lot of these use cases are, based on your requirement, based on what's available through the connectivity. And there's a lot of freedom and a lot of capability on what you want to connect to. So what? So we've got an integration platform. It can connect to these various services. It can orchestrate this data. So what? Why are we here? So we've got a couple use cases that kind of demonstrate the value and the capability of Oracle Integration Cloud, not only as kind of the upstream funnel of this data where you can integrate with these various applications and services, but also somewhere where it can handle kind of these complex outputs or more sophisticated data sets. So we discovered when we were working with some customers on these use cases in two scenarios that this JSON ingestion process really brought a lot of value to the table and linked up with the base capabilities of OIC quite well. So in this first use case, we've got a standard EDI B2B type use case where you're interfacing with the trading partner who's sending you some purchase orders, standard 850 purchase order documents in an EDI X12 format. We're reading that into OIC, into Oracle Integration Cloud, into our middleware. However, the challenge that we faced and that, a lot of customers brought to our attention is, what if we had a requirement where we wanted to translate this document and then put it into a data warehouse for safekeeping, for analytics, for reporting, whatever reason you need to downstream? Is these documents can be fairly sophisticated and complex with how their data is structured. So you see here on the left side, which I'll show in the integration, this is how a lot of the data is shown, which is, it's not as simple as just calling an API and moving some data in a nice old flat JSON structure. There's various loops, there's various segmentation, there can be repeating elements within repeating elements. And, it's kind of a complex structure for a document, and it brings up challenges when you are, trying to insert that or give that to a table structure, an autonomous data warehouse. So through this JSON ingestion process, we're able to actually just carry this output, in our case, over to object storage as landing zone. Then you can initiate that process and allow the autonomous database to pick it up from there. In a similar vein, instead of pulling from an EDI document where a trading partner might send you a purchase order, we found a similar pattern with certain Fusion APIs, Oracle Fusion SaaS APIs, where maybe you want to pull, in this case, some supplier level data, but you can also pull various child elements off of that business object as well. So you can pull addresses, contacts, sites, things of that nature, in addition to that base, supplier API. And that can introduce complexity as well, because now not only you have your base supplier information from the API that you want to pull into the data warehouse, but you've also got these various repeating elements, these various arrays in kind of this nested fashion where, you got to loop through them, you got to pull from, various indexes. And again, it kind of introduces some complexity in this handling of this downstream data structure. Again, hence where the value of this JSON ingestion process comes up. And now to show what an actual integration might look like with these two use cases that we've built out or encountered. So here I am logged into Oracle Integration Cloud, OIC, and this is a Gen 3 instance. And to start off, I'll go through this integration here. So this is thinking back to that EDI document ingestion. So I'm receiving an 850 purchase order from my trading partner. So if I go ahead and run this, it'll bring up the testing tool in Oracle Integration Cloud. And I'll provide an 850. So I'm kind of like the trading partner who's going to send this off to me. And I will run the integration. So what the integration will do is it will consume this 850 purchase order, and then it will translate it into its JSON equivalent, and then return that data to me. So the integration ran without issue, and I get back this JSON payload. So this is now the translated 850 purchase order. And as you can see here, it's kind of a sophisticated JSON array in here. We've got some segmentation with ref, we've got all sorts of repeating elements. We've got loops that we have to loop through. So it's got some complexity to it. It's not as straightforward as just taking everything and mapping it to a table and calling it a day. Hence, again, why the value in the process of this JSON ingestion comes into play. And just for a better visualization as well, I've got this up in a text editor. Going through all of these items, all of these loops, looping through, repeating arrays where they are, can be kind of a headache if you're doing it by hand. So that's what that particular EDI document looks like on the output for JSON. And we push it as JSON because it's a fairly universal data format used by a lot of various applications and systems. And it's kind of like our canonical format, as we call it in Integration Cloud. Fusion ERP is in a similar format. So if I pull up what a sample like that might look like. So this is our response. For the base API, for the base URL, it's fairly straightforward. Really not a whole lot of complexity there. It's just a kind of a flat payload. But once you get into the child elements where OIC and the adapter will actually go and query, in this case, this is supplier data, but it's also going to go and get sites, contacts, addresses. Really, this JSON becomes kind of a behemoth of a payload, and you have to loop through various child elements, and it becomes a little challenging to map that to a direct table format or direct schema and autonomous database. So yeah, just wanted to show that. And again, this is kind of setting up for pulling from our various data sources, translating that into JSON for preparation to send to a downstream system. In our case, it's going to be an autonomous database, but ultimately running into some challenges with the complexity and kind of the nested arrays and kind of the sophistication of that JSON payload, in which a process like this would be helpful after we prep this data and get it all ready for this process. With that, I'll stop and I'll hand it over to my colleague Derek.
Thanks, Wilson. So first I'll just do a very brief introduction to the database, the JSON in the database. For those of you who have worked with ADB at all, autonomous database at all, you probably are already aware that we have 3 different versions out there. We have the ATP, which is transactional database version. We have the JSON version. We have the data warehousing version. The JSON version is just another autonomous database at the end of the day. In fact, it's really an ATP instance, and to convert it from JSON to ATP, it's a single click. So why do we even offer it? Well, it is priced much lower. So if all you care about is JSON, then you can go with the JSON database. And if you decide sometime in the future that you want to combine that with relational transaction processing with the JSON, you can do that. So there's no kind of upfront decision that you have to make. You can start with JSON. If that's all you want to do, you're going to save money. There are limitations, of course. It exposes just the JSON features, unlimited collections, but 20 gigabytes of non-JSON data. And that is similar to, that's the same as the always free instance. You get the ATP. I have an ADW instance. I do a lot of analytics, and I didn't want to spin up another database just for the JSON. So everything I'm doing today is actually an ADW. So let me just move on. So why store JSON in the database? First of all, one thing that's very unique to the JSON that's not like relational is it's schema flexible. I think any of you know, if you built an application in relational tables, you need to build out all the tables. You just don't alter table, add column, create new tables on the fly with applications. It's application controlled schema. So if you want to add tags, if you want to add, say, a color to your part description, you can do that. And it's not going to break anything in the database. So it's very, very flexible. It's a simple data model. In fact, we call it schemaless, but if you're going to do analytics on it, we do have to create a schema, and we've got utilities to do that. There's some examples. Easy data access as well, REST enabled. It has a NoSQL API interface. I'll show you a little bit of that. But I will be focusing more on SQL today. I'm a sort of 30-year veteran of the database. I've been working with the database for decades, and JSON's relatively new, but if you really want to use the NoSQL API, you can do that as well. So JSON collections, bit of terminology here if you're new to it like I am. Think of a collection like a table on the relational side. A collection, when you create a collection in the JSON console, it creates a table. And then a collection contains documents. Think of documents as rows in that table. Now, strictly speaking, it's actually a column in a row. So you add a document, it's going to add a row, it's going to insert JSON into a character. It's going to be either a varchar, a character large object, a binary large object, or 23C. It's going to be a native JSON binary format. I would just caution you on the documentation. There's been a lot of new JSON features added since 12, 12.1, 12.2. I have literally run into a little bit of confusion not paying attention to those versions. There's been new SQL operators added on 12.2, 18, 19, 21, and 23. So I tell myself every time I'm looking up a blog or looking up documentation, pay attention to the version number. You can work interchangeably. You could have a table that has 250 relational columns and a JSON binary column, and you can present the JSON as a table. That is the internal structure of JSON as relational tables and rows, and you can do vice versa. You can take a relational table and present it as JSON. There's SQL operators for all of that. There's just a very simple way to do this. Create table, in this case, movies, 3 relational columns and 1 JSON column. And you can store them side by side in the table. They both coexist. And then you can use SQL operators on both of them. You can do analytics. I'm going to show you at the very end dashboards in OAC querying data in that JSON data type. There's an example. Make the JSON look like a table. Create table. There's the JSON on the left. There's the query on the right, and then the output looking like a typical relational query. So let's go into the interface now. So I've got 2 collections here. I created this one with the SOTA interface here, and you can easily create it by simply clicking on that, give it a collection name. It's an empty table. It will create a table of the same name on the relational side, and I will show you what that looks like. The data that I inserted into, I simply added documents here, literally cut and paste, but you can also import documents into your collection. So if we scroll down here, you'll see that there. So question, what does it look like on the relational side? I use SQL Developer Client. There's the products collection created by that SOTA interface. It did this for me, created an ID, created by modified version data. There's the 4 records. The actual JSON is stored in blob. It could be clob, it could be varchar. Blob has got some advantages. I won't go into that right now. Let's go back to the interface here, and I am going to clone one of these, and I'm going to give it 999, and I'll save it. I'll create it. What did it do on the relational side? I just requery this, and there's the row. So you can see how that works. I go in here. I want to delete the column in here. I don't need to use the SOTA API to do that. So again, I'm a SQL guy. That's my preference. And so I delete the row. I go back here. This here is like a blind query. And so if I scroll that, then the record's gone again. So there's a couple other things. I'm not going to spend that much time in here, but there's a couple of things I want to point out. One is this schema, this ability to sort of reverse engineer the schema, the internal schema, by reading the data, I found this incredibly useful. This is a very, very simple JSON structure. I'm like, yeah, that's fine. But the JSON I'm working with is, as Wilson had pointed out, can get pretty complicated. And so I uploaded this, and I literally hand wrote a lot of SQL, and I had the notepad, just like Wilson. I had the notepad open, and I'm like, oh, what's shipping instructions? And I've got within that name and address, and with an address, street, city, state, and I got multiple phone numbers in an array. Oh, and line items, there's 5 line items to this one PO. It's all one document. How can I visualize that? Well, this is what it looks like. It's got the data, it's got line items, multiple line items. You can see it say, in this case, many to one, in this case, many to many. And so this is a really incredibly useful utility for interrogating that JSON and presenting it so you can understand it. And so you're going to imagine, if you were to try and translate this by hand into a relational structure, well, you'd probably have a table, and you'd have, oh, you want to update the document? Oh, well, you need to update the part needs to join to the line item, down to the data. It gets complicated. The beauty of JSON is it's all in one document, and you have an API to update it, and it's really, really simple. You can use SQL as well, and there's SQL operators to do that. Now that I've got that, let's just do a couple of examples of the SOTA API. If I look for PO number 10, very simple to specify that. Let's look another one. And I'll be doing some of this on the SQL side. I want shipping instructions, and you have to specify the path. That's important. You have to specify the path. But we'll show you on the SQL side how to crawl through the whole document and find strings in the document. In this case, find a city, San Francisco, nested in an array lower down. And then the last one I'll show you before I spend more time on the SQL side is the ability to do kind of wildcarding. Instead of just equals, let's do a like Trina, Raj. So you can do that. So really kind of pretty useful. Now let's flip back to SQL Developer. I'm going to spend a little more time in there. Those collections are in metadata. So if you'd say, well, what collections have I got? Well, I've got the 2 collections. I showed you that already. You can add a check constraint. So if you want to put, just very, very similar to a relational check constraint, you can put check constraints on JSON. So if I go into products collection here and I look at constraints, there it is. JSON exists, title type, string price.number must be greater than 0. So that's a check constraint. And when you created it, all these other ones were automatically added. JSON is JSON, so it validates that it's real JSON. If you don't have that constraint on, you can literally put garbage in there and there won't be any errors until you actually try to query it. So let's go back to here. I'm going to walk through a few things. There's some functions here I'm going to go through. Select JSON, serialized. Serialized data is like, show me the JSON in the data. There it is there. And if you go in here and go single record view, it's all kind of flat, and it's like, oh, okay, I don't really see the structure. So the really nice thing, it's got this, oh, show it to me in structured format. I think I can just go there. And then if I go right click, single record view, and then I edit it, there it is, format. That's kind of handy. Again, I was crawling through it until I got to the documentation on presentation. There's a dot notation. So it's like a key pair. So where the data dot type is being string is movie, the format is DVD. This is SQL now querying the binary large object that contains JSON. Okay, just to be clear here. And just like any other SQL, you can aggregate it and join it with other relational data. Super, super powerful. Now, there's a really kind of nifty feature. I hand wrote a lot of this stuff, but if you go into here, go into the collection and go into create view, add all the columns here, test the query. There it is there. I don't need to handwrite it. I can generate a SQL view using this view creator. Now it creates a very specific view. It's all the columns in the table. It's a JSON table function. And so if we go back to SQL here, and if I want to run this, I can just hit the select statement there and query it. And there it is there. This is where we're going with this, right? It's the ability to do analytics on this, just like relational, and combine it with relational table, but even use it for analytics within the JSON itself. So next, loading data. Wilson's already loaded the data. We have this application, the use case involved loading data, but what if you had to go back and load a whole trove of data, like thousands and thousands of documents? What if you had integrations that involve dropping files in object storage? Well, first of all, to do that, you need a credential to read object storage. But then once you do that, you can create and load a JSON from relational table. Where is that? Where is that data? It is in object storage. It's this file here in object storage. I'm going to load that there. So let's go here, go back to here. And if I do DBMS Cloud copy collection, this code here reading this file here will create this table here for you. So instead of using the SOTA API, I can actually do it right here. And once I've done that, I can index it, create a domain index on everything in the JSON data in the relational table. Again, pay attention to versions. Search indexes, well, it's not that new, but it did come out in 12.2. And then there's another index, a more specific index. So you might say, well, Derek, you told me I could index the whole JSON document. Sure, this is a lot slower. This is a bit like a B-tree index looking up a record. It is way, way faster. And so let's take a look at that. There's the query again, select data. There it is there, again, showing it like relational. Search for data anywhere in the document. Now think about it. If you had to do this in a relational schema, you would have to query every table that's part of the purchase, which is batches, headers, lines, and maybe customers and maybe addresses. And you might have to search 5, 6, 10 tables and every column in that table. Well, if I want to do that with a JSON search, I say, scroll through the whole document, show me where that the string princess exists. Now, there's an important point to do with this search index. It only works on full words. So if I just literally chop one letter off that here and I query it, what it does is it doesn't error, but it doesn't find the record. So that's a kind of something you need to bear in mind. So if we run the explain plan, we can see, just like Oracle, any other relational query, you can see that it's accessing, because it's a requester. Remember, we put a very specific index on requester. There it is there, purchase order requester index. So you can use explain plan if you want to do some optimization, understand how the data folks are accessing the JSON and tune that up. Inserting data, pretty simple. Insert into purchase order collection values. I'm actually not going to do this. It's very straightforward. I insert it, you commit it, then you can see the data, see the record, and then I can literally go back into here, because I'm inserting this one into purchase order collection. You'll see it right in the data here, inserted. There it is there. And whoops. Sorry. My Apex is insisting I look at it. So you can insert rows just like any relational table, but you're inserting it into JSON structures. You can see it there. Utilcast to raw. That function there is because it's a binary large object. Look up the syntax for clubs and varchars. It is simpler. You don't have to use the cast to raw function. Data update. I can update the data here. Now, there was up prior to 19C, and I'm using 19C, use merge patch. Merge patch is really good for updating large chunks of a JSON document. Like if most of the document's changing or much of it, use merge patch. But in 19C, they came out with JSON transform, much more finer control. You don't need to update a whole JSON document. You can update individual records. You can insert items into arrays. You can actually delete items in arrays in a nested array. So super flexible. And by the way, all of this code will be given to you in a Git repository at the end of the presentation when Tara publishes the recording back out again. You'll have a link to a Git repo with all of this code, including the JSON that I'm working with. So data guide. So I wrote a lot of hand SQL before I ran into the documentation on data guide, and data guide is now my new favorite JSON feature. It retroactive, like it crawls through the structure and creates the metadata for it. So all of the views, everything can be actually generated using data guides. So you have to create the table data guide, and that's it here. That's data guides right there. And then you're going to load the JSON structure, like go crawl through this and tell me what it looks like. And that's that insert into purchase data guide. And there's a JSON data guide function, and then create a view using the metadata in the data guide. And so you can generate that view, and super helpful. We're not having to go into the console in the database. You can actually use SQL, love SQL. And then let's take a look at what that looks like. The purchase order view is right here. So the first observation, me being this kind of legacy Oracle database guy, is like, oh, you've got mixed case in here, which means every column must be fully qualified with double quotes. That's not good development practice on the database side. It even has spaces. I know a lot of you working with SQL Server, that's like, yeah, that's the way it's done. I find it very tedious because you can have code that's camel case, init case, whatever. If you just define it like this, it doesn't really matter how you specify it. You don't need to double quote anything. So I literally took the SQL from this view, and you can pick that up literally by just going here and hitting SQL. I know it's a little slow on SQL Developer. I won't do that, but you can get the SQL here. And then what I did is I rewrote exactly the same SQL, the view, only I just didn't double quote things. And so then you end up with this, which is much more conventional SQL. And then I did a couple things. I wanted to look and explore some options on creating the views, and you can create a view on the path. Well, what is that? Well, creating a view on the path means you don't need to create a view on the entire structure. So if you go to version 3, this is what it generates. That's all the columns. I want to create the view on the data starting with the reference tag. So what does that look like? Well, it drops all the item numbers. The item numbers are nested. I want a view on that. So it's a bit like creating tables that master detailed tables separately instead of duplicating the rows. And the way to have a look at that is if I go back into here and I go to here, what I'm talking about is I can do it at the root, and it'll create replicating rows for all of this, like, because line item, there's 5 line items, well, there's going to be 5 repeating rows of values here, right? So what you can do is use the create view on path by creating a view for that, and then separately a view for the line items, which there's only 5, and separately for part, and there's only 1 there, and so you can kind of a little reverse engineer this without. So you're normalizing it. To be clear, I'm normalizing then instead of creating a fully denormalized table. So let's look at that. Go here, and then I look at number 5. And remember, 5, that view is from the line items table. If I look at what the data looks like, it's going to be this, and it's 5 line item rows. 5 line item rows. So you then get really a normalized relational structure. Do you want to do that? Well, for analytics and for slicing and dicing, you might want to do that. If you're going to be just working with the JSON data and transaction, like people like Wilson, he doesn't care. He's supporting the application, the integration, the pulling of the data. It is what it is. We put it in here. We care about it if we're going to do analytics on it. So we'll go back to here. So that's the view on path. And you can also get the SQL, by the way, just FYI, you can get the SQL. I won't do that. It's in your code. You can explore that. External tables. You can create an external table. What is an external table? It is a SQL view on top of the data that's in object storage. Well, that's external tables been around from the beginning of time, but think about it. People are dropping JSON documents in your object storage. You don't even need to load them to query them. And so you can create an external table on it. And then we're going to query this file. It's that PO file I showed you. It's not in the database, but it's pointing to that. And I'm going to query it. It's a little slower. You notice that? It's a little bit slower, but it's querying the data that's in that file that's in the database. So there might be a use case where you're like, hey, I don't want to load it, but I want to have access to all this historical JSON data, and I want to do analytics on it. This would be a good use case for that. And then before I get into the final bit with the analytics, I want to show you formatting relational to JSON. You can reverse it and go back the other way. You can use the DBMS Cloud export data, and I did that, but it can't faithfully, let's go back to this, it cannot faithfully reproduce this because just the repeating rows, the information simply isn't in there. And so what I'm gonna do is show you how we, let's go back to SQL. What I ended up doing is like, okay, I'm gonna reverse engineer it out. And so I created this query here to initial root level, value pairs returns 5 rows for each PO. I had repeating rows. I had to do a select distinct to remove that. And then I had to pull out the line items. And then I stitched it back all together. I know it's a little bit of code, but the point being is this, is that you can reconstruct SQL, any which way SQL from the relational data. And so if we look at what the data looks like there, we go back into here. And it's this one here, and there it is there. There's the data. PO number, I can sort it. PO number 1, blah, blah, blah. If you look at this string, it has faithfully reconstructed back out everything that you see here, including the nested arrays and everything. So it's really just conveying the fact that you have really a huge amount of control, especially with all the JSON functions that have been added in 19C. And there's really exciting new functions in 23. I'm not on 23, so I can't show those, but they are available on the download, like, 23 is available as a download now. So the last thing I'm going to show you is let's just go back to SQL Developer, make sure I've covered everything. So that's that there. Again, you'll get all this code. You'll have all this code. You can reconstruct all this. Let's go back to here, and I'm going to close that, and I'm going to go to analytics. Whoops. So yeah, I'm a BI guy. I am an analytics guy. I spent a lot of my time there, and database. I worked with database since 1992. And so, and I did analytics a lot for all those years. And so I thought, okay, well, let me build a dashboard on this purchase order data in JSON. And so those views, of course, exposing it as relational objects, I can now plot item quantity by part unit price. You can hover over that. I've got a tree map here. This could be on an external table. It could literally be crawling through data in files in object storage. Again, this was, I swear I created this whole dashboard in an hour. So it's super easy to do that. I created a tag cloud on the description of the parts in those purchase orders. It's all nested n levels deep in a JSON structure, but I queried that simply. I defined a data set here, did querying. Now I'm going to analyze it by requester. People are requesting POs. Who are those people and what are they requesting? All right, so I've set this to be a filter. I just click on a bar here. And again, crawling through using SQL functions, crawling through the JSON, and here's all of my POs. The item quantity within the PO is 47 POs with items, 197 items. You want to click on Kevin here, bang, slice and dice it. And because it's got a city, there's nothing easier than presenting things geographically based on the city, because that's all baked into the OAC platform. I want to see Seattle POs. Again, I just pick up on the fact that it's Seattle, Washington. It knows where it is. And if you had more precise PO data with long and lat, or even an address, we can reverse engineer it in the database and get the long and lats and present them as individual items on a very detailed map, just like Google. So yeah, with that, I'm just going to switch back and just explain a little bit about the Code Innovate program. Wilson and I are on the Code Innovate program. We work with customers every week building prototypes, and Wilson and I often work together with integrations that are using the database. So a lot of the stuff that we kind of come up with in these webinars is due to the customer, the customer facing Code Innovates. Well, what is Code Innovate? Well, let's go into that. The Code Innovate program, I think it's best explained with our manager. This is his kids. He came up with this idea, and I think it's a great analogy. Every year he takes his kids to Legoland. And at Legoland, the whole exercise is to teach the kids how to build something. And so they're assisted by this master builder person. He's got all the knowledge about the Lego. He guides them. The kids actually sit down and build something. In this case, it's the little penguin. But the point of this whole thing is they're building something. They are building it with the assistance of an expert in the room. Well, of course, the analogy is you build something that you need to, like it's a problem or some kind of business case. You build it. It's not theoretical, it's physical. You build a solution, first pass prototype with the assistance of the master builder. It's not a POC because we don't build it, you build it. It's hands-on introduction to cloud services. Our engineers work with your online team online. We do it in Zoom in breakout rooms. It's meant to be really fun. We've got recordings of about 280 now, quite a few, with many of the customers coming back and doing them. Facilitates very rapid knowledge sharing because you're hands-on all week. It's half days, usually morning or afternoon, 5 days, Monday to Friday. Leverages your use cases. It is free. Wilson and I are in sales. We're here to get our customers familiar with the cloud services. We're encouraging folks to use the services. So we offer this as kind of a way to do that. And so we work with your use cases, showing and instead of using canned demos, right? This is not like take demo data. No, it's your data. Our engineers with your team, 4 hours each day, and we build a first pass prototype of your use case at the end of the week. And so, yeah, if you are interested in the Code Innovate exercise, like the events, we just feel free. And this will be provided to you as part of the recording, but email us at codeinnovateusgrp@oracle.com. And or enter your emails in the Zoom chat and we will contact you. Again, when Tara sends out the recording, she will publish the Git repository with all my code plus the file. You'll be able to go right back, literally just go through all the material again slowly, take a look at it, query it, understand it. And Wilson as well will reach out to any of us on the team if you have any questions.
Thanks again so much. We hope to see you at the next one.